So, the scientific method is heavily dependent upon making measurements. So, we're going to need some standards for making those measurements so everybody can judge the quality of them and whether they are reliable or not. One difficulty that we encounter in science is that frequently we're dealing with very big numbers and also very small numbers. And very big numbers have a lot of zeros on the right hand side, and very small numbers have a lot of zeros on the left hand side of the number. And so they're prone to being read incorrectly, and they're prone to being recorded incorrectly. Also, it's just difficult to write a number that has a lot of zeros. If you think about a calculator, it only has so many spaces that you can actually enter in numbers, and it isn't actually possible to enter infinitely large or infinitely small, or even very, very large or very small numbers into a calculator. So for these reasons and others, a method of writing measurements known as scientific notation was invented. There's also other methods for kind of overcoming these issues. One of them is called engineering notation, and that's kind of an older system, and we're not going to be using that system at all. So, decimal numbers become difficult to use and are prone to error when we're dealing with very big and very small numbers. And these kinds of numbers are pretty common in chemistry. So, to help us kind of get around some of these issues, we're going to learn to use a type of notation called scientific notation. So, in scientific notation, every number is written with two parts. There's what we call a coefficient, which is a number that has only one non-zero number to the left of the decimal point, and then that coefficient is multiplied by a power of 10. So the power of 10 could have what we call a positive exponent or a negative exponent, and the power of 10 that we're multiplying by is often referred to as the exponential term. So I should label some of these things here. So the whole power of 10 is often called the exponential term, and that little number up there is the exponent, and it can be a positive number, it can be greater than 0, and it can also be a negative number. So here is 110,000 written in what we call a decimal notation. So decimal notation just means conventional notation. And here is the same number written in scientific notation, where we have our coefficient multiplied by our power of 10. Those two numbers are equivalent. So an exponent is just a number that's written in a superscript following that number, and that other number is often referred to as the base. So if I write something like this, 3 to the power of 5, the base is 3 and the exponent is 5. And the exponent just indicates how many times that number is multiplied by itself. Now, in scientific notation, we're always dealing with terms where the base is 10, and then perhaps we have the exponent is a positive number. So sometimes these exponents are referred to as powers. So we would call this as 3 to the power of 5 or 3 to the 5th power. So this would be 3 to the 4th power or 3 to the power of 4. So you kind of get used to that kind of language. Some of these powers have special names. Raising a number to the second power is described as squaring the number. Raising a number to the third power is described as cubing the number. Most calculators have a feature, because squaring is so common, that you can actually do it with one button press. Negative exponents are possible, as I mentioned previously. A negative exponent indicates the base and the power to which it is raised are the denominator in a fraction with a 1 in the numerator. So what does that mean? It means like this: if I have x to the minus y, that is the same as 1 over x to the y. Now we'll often see this where people want to write everything on one line rather than entering fractions, and that's common on a computer. So if I see something like this, kilograms meters to the minus 2, you'll see that people will very quickly, without even blinking, flip to writing it like that. So people will just kind of like move between a negative exponent and the fraction without even kind of really indicating how they've managed to do that. It's just kind of like understood by people who have technical expertise. So 3 to the minus 2 is exactly the same as 1 on 3 squared, right? 2 to the minus 5 is exactly the same as 1 on 2 to the power of 5, and so on. So this often comes in with the labeling of units. So speed is distance over time, and so this was meters over seconds, but it can equally as easily be written as meters seconds to the minus 1, because seconds to the 1 is on the bottom line there. Takes a little bit of getting used to that kind of labeling, but it's very common in science. Okay, so you want to get used to evaluating some of these things in your calculator. Most calculators require you to enter the caret key following a number in order to raise it to a particular power. So I'll show you how to do that now. So I've just popped up my scientific calculator here, and I'm going to enter in these things here. So we've got 3 to the power of 6. There we go, and there's our answer. 10 to the power of 4. And you can see I'm just hitting that caret key in order before I enter the power that I'm raising to. 9 to the power of minus 2. There we go. 8 to the power of minus 1. And as I mentioned, most calculators have this square feature built in. So I could do 3 squared. And you can see this calculator also has to the minus 1. So I could do 8 to the power of minus 1. And there you go. Alright, so the only other thing that I'd like to point out about the calculator is the minus key is different from the subtract key, so be aware of that. Okay, so scientific notation only uses powers of 10. So, it's always going to be base 10. And so when 10 is raised to a positive power, what you end up with is a 1 followed by as many zeros as the power of 10. So 10 to the 0, or 10 to the power of 0 is 1, because you get a 1 with 0 zeros. 10 to the power of 2 is a 1 followed by 2 zeros. 10 to the power of 3 is a 1 followed by 3 zeros. 10 to the power of 4 is a 1 followed by 4 zeros, and so forth. So it's really easy to kind of see what you are multiplying by here, right? So 1.10 by 10 to the 5 is equivalent as 1.10 times by a 1, 1, 2, 3, 4, 5. There you go. So it's 1.10 times by 100,000. It's pretty easy to see what you're doing. What about the negative powers of 10? So when 10 is raised to a negative power, you're always going to end up with a number less than 1, right? So 10 to the minus 1 is the same as 1 over 10 to the 1, which is the same as 1 over 10, which is 0.1, and so forth. 10 to the minus 2 is the same as 1 over 10 to the 2, which is the same as 1 over 100, which is 1/100th, or 0.01, and so on. So what you want to recognize is that when you have a negative exponent here, the absolute value of the power of 10 is always 1 less than the number of zeros between the decimal point and the 1, which is kind of confusing, right? So if I've got 10 to the minus 1, then the absolute value of minus 1 is 1, and then it says that is always 1 less than the number of zeros between the decimal point and the 1. So take away 1, I'm going to have 0 zeros between the decimal point and 1. So 10 to the minus 1 is just 0.1. There are no zeros. All right. Now if I go to 10 to the minus 2, I'm going to get 1 0 between the decimal point and the 1. 10 to the minus 3, I'm going to get 2 zeros between the decimal point and the 1, you know, and so forth. You don't have to go through all of that math. You just have to remember 3, I'm going to get 2 zeros. 2, I'm going to get 1 0. Minus 1, I'm going to get no zeros, right? Pretty easy kind of procedure. It's just identifying how many zeros I'm going to get after the decimal point. So another little bit of language, a power of 10 is often referred to as an order of magnitude. So if I have 10 to the 3 and I'm comparing that to 10 to the 5, I'm going to say that they are different by 2 orders of magnitude. All right, you see that? There you go. All right, they're different by 2 orders of magnitude. So 10 to the 4 is an order of magnitude larger than 10 to the 3. 10 to the minus 2 is 4 orders of magnitude smaller than 10 to the 2. So scientists are going to talk like that. 1000 is 1 order of magnitude larger than 100, right? Because that's 10 to the 3 and that's 10 to the 2, right? 0.001, or what we'd call 10 to the minus 3, is 1 order of magnitude smaller than 0.01, which is 10 to the minus 2. So you get the idea. You just kind of have to get used to sometimes people throwing that language at you. Otherwise, you might get lost. Okay, so how do we convert between normal decimal notation and scientific notation? Well, it's pretty simple. We've got 2 things that we need to decide. We need to decide what we call what our coefficient is, and then we also need to decide our power of 10, right? So let's work on the coefficient because that's super simple to do. Remember what I said about the coefficient? It always has one and only one non-zero number to the left of the decimal point. So the first thing that you're going to do is you're going to take your number and you're going to write it, or you're going to place a decimal point so there's just one non-zero number to the left of the decimal point. It doesn't matter whether it's a big number or a small number, that's how you're going to get your coefficient. You're just going to move the decimal point or place a decimal point so that you have one non-zero to the left of it. Okay, so once you've got your coefficient, then you need to decide on your power of 10, right? So this is how we're going to figure out the size of your power of 10, what the absolute value of your power of 10. And that's just equal to the number of spaces that the decimal point was moved. So in this case up here, we're going to move the decimal point 1, 2, 3 spaces. So the size of my power of 10 will be 3, right? And in this case, I moved my decimal point 1, 2, 3 spaces. So the size or the absolute value of my power of 10 will also be 3. But now I've got to decide the sign of my power of 10. So what I've got to recognize is if I start with a small number that's less than 1, then the sign on my power of 10 will be a minus. And if I begin with a number that was greater than 1, then the sign on my exponent will be a positive number. And so that's it. So you really got just sort of like, 2 bits. You've got to figure out the coefficient, which is super easy, because we know it only has one non-zero to the left of the decimal point. We just got to move our decimal point, so that's the case. And then we've just got to figure out the size of our power of 10 and whether it has a positive or a negative sign. So it's not too hard to move between these two systems of decimal numbers and scientific notation once you get used to it. Okay, so here are a few examples. I've got 5,015. So this is a big number, so I know I'm going to have a positive power of 10. And so now I've just got to figure out what the size of my power of 10 will be and what my coefficient is going to look like. So I rewrite my number so that the decimal point just has one non-zero to the left. So there it is there. And then I count how many spaces I had to move the decimal point to get to that point. So it was 1, 2, 3. So I know that I've got to multiply that by 10 to the positive 3. Okay, in my next one, I've got a number that's less than 1, so I know my power of 10, I can almost write it out immediately, is going to have a negative exponent. So now I've got to write my coefficient, which is just my number written but with the decimal point placed so that there is only one and one only non-zero number to the left of the decimal point. So 1.22. And then I count the number of spaces that I had to move the decimal point to get that coefficient, and that's what goes in my power of 10. So it's pretty simple, right? Now, later on, we're going to learn about significant figures in this chapter, and what you'll find is that the number of significant figures, the number of important numbers in your measurement won't change when you move from decimal to scientific notation. So you don't lose any information when you make this move. And that'll be more meaningful to you a little later on. So here's our third example here. We've got to write our coefficient with the one non-zero number to the left of the decimal point. So to do that, we're just going to move our decimal point 3 spaces. And then we're going to multiply by our power of 10, which, because we're starting with a small number, we know is going to be negative. As we moved our decimal point 3 spaces to get our coefficient, it's going to be -3. So it's not that hard, and with a little bit of practice, you're going to get real good at doing this. Okay, so the ALEX topics for this are actually pretty simple. So I'm just going to pop my calculator up again. There's my calculator, and your calculator is going to do all of your work here. So this one is about division of a decimal by a power of 10, and this is so simple, isn't it? 4.63 divide 10. It's all just about not making a mistake. So 0.463. 0.463. Okay, let's try next one. Now it says write this number in scientific notation. So the first thing I'm going to do is I'm going to write my coefficient 6.419. I just moved the decimal point so that I had one non-zero to the left of the decimal point. Then I'm going to multiply it by my power of 10. And I know it's going to be a negative exponent because this was a small number. And now I've got to decide the size of the exponent. 1, 2, 3 spaces. I move that guy. And there I am. There's my number in scientific notation. Now it turns out that your calculator will also do this for you. If I change the mode to scientific, not engineering, scientific, there we go, enter. And I'm going to quit out. When I put the number in, and I ask it to return that number, if I just hit enter here, it'll convert it to scientific notation for me. You see that? All right. And that's really cool. Now see how the calculator displays scientific notation. It doesn't write 6.419 times 10 to the -3. It writes 6.419 e to the e minus 3. So that kind of takes a little bit of getting used to. That e means times 10 to the power of. And we can also enter numbers like that. So I'm going to show you this now. I'm going to go back the other way and go mode. And I'm going to go into normal mode. There we go, back to normal mode. And I'm going to quit. And I'm going to put this in 6 0.419, and instead of writing out times 10 to the power of minus 3, that's a lot of buttons, I'm just going to go second function, and it puts the e there. See this E? It puts the e there, and then I just go minus 3. When I hit enter, it's going to give it to me in decimal, as a decimal number. Here we go, boom. You see it, and I turn it back. So using the mode feature and using the E there, I can easily flip between the two modes. Pretty easy going. Okay, finding negative powers of scientific notation. So I need to put this into my calculator and get my answer. Now, what do I think my answer is going to be? It's going to be minus 5 times 10 squared. So if I did that longhand, it would be like this. Minus 5 times, and then 10 squared would just be times by 100, all to the minus 2. So then that would be minus 500 to the minus 2, which is the same as 1 on minus 500 squared, yeah, which is equal to 1 on minus 500 times minus 500. Now I wouldn't want to be entering all of that into my calculator. Now what's 500 times 500? It's going to be a really big number, isn't it? But that's going to be 1 over that, so it's going to be really small. Now that's a lot of work. I could do all of that, but let's just do it real simple. Let's just enter it exactly as it's written. So, parentheses, minus 5, second function, e, 2. Close parentheses, and then just to the power of minus 2. There you go. Minus 5 by 10 to the 2 to the power of minus 2. And it should be 1 over a really big number. Remember, it's going to be 1 over 500 times 500. So that's going to give me a tiny little number. And there it is. 4 times 10 to the minus 6. Write your answer in scientific notation. So it's already in scientific notation, isn't it? So 4 times 10 to the 6. All right, there we go. Okay, so practice with your calculator. If you don't have a calculator, you can use an online tool like Desmos or Wolfram Alpha. You probably know those sites, Desmos, Wolfram Alpha. We use those a lot in math classes. Either of those can do that. That E as being equivalent as times 10 to the power of, that's really important, just like that. So if I have, like, 1.6 e minus 9, that just means 1.6 times 10 to the power minus 9. Most of those calculators and these websites will use this kind of notation, and you really want to get in the habit of using that, or you're going to make a lot of errors. Anyway, fairly short section. Many of you have seen this before. If you haven't, I hope that the review was helpful. And yeah, if you've got any questions, please just let me know.